Hi students, in this video we are going to cover electric current and the resistance. As a physical quantity, current is the rate at which charge flows past a point on a circuit. As depicted in the diagram below, the current in a circuit, this is a wire. So when we take a segment and enlarge it, the current in this segment can be determined if the quantity of charge Q, you see here, passing through a cross-section of a wire in a time t can be measured. So simply I can say that the current is equal to the charge passing in unit time. So in symbol, the symbol of current is I is equal to the symbol of charge is Q and the symbol for time is T. When we take the Q in coulomb and the time in second, I have the current in ampere, the symbol A, which is equal to coulomb per second. In a metal wire, the charged are carried by electrons. You see here, these are the negative charged particles. These are the electrons. Electrons are the moving particles which carry negative charges, because here the protons do not move. But in an electrolyte, we have positively charged ions and negatively charged ions, and both ions can move. So they both carry or form current. So when we in an electrode, we take the total charge carried by both positive and negative ions over time in the calculation of the current. But in a metal wire, I only use the charge carried by the electrons in unit time to calculate the current. The direction of current is from positive to negative, so you see that it is the opposite direction of the flow of electrons. Let's do an example. We have a 2 mm long cross section of wire is isolated and 20 coulomb of charge pass through it in 40 seconds. So current is equal to charge over time. The amount of charge is 20 coulomb. The time is 40 seconds. So I have 1/2 or 0.5 ampere of current. Now sometimes the number of electrons are asked, how can I calculate it? We know that one electron carries a charge of 1.6 times 10 to minus 19 coulomb. So I have 20 coulomb of charge. So how many electrons carry a 20 coulomb of charge? So the number of electrons is equal to 20 over 1.6 times 10 to minus 19 electrons. A 1 mm long cross section of wire is isolated and 2 coulomb of charge pass through it in 0.5 seconds. So the current is equal to, from charge over time, 2 coulomb pass in 0.5 seconds, which is equal to 4 ampere. The number of electron, again one electron carry a charge of 1.6 times 10 to minus 19 coulomb. So how many electrons carry a 2 coulomb charge, which is equal to 2 over 1.6 times 10 to minus 19 electrons. Resistance is defined as the restriction of electron flow. It is due to the interactions that occur at the atomic scales. For example, as electrons move through a conductor, they are attracted to the protons on the nucleus of the conductor itself. This attraction doesn't stop the electrons, but just slow down a little bit and cause the system to waste energy. The unit for resistance is ohm, and the symbol of ohm is omega. Variables affecting electric resistances are: first one, the length. The longer the wire, the more resistance there will be. Second, the thickness of the wire or the cross-section area of the wire. The wider the wire, the greater the cross-section area and the less the resistance is, and the material it is made of. You know that not all materials are created equal in terms of their conductive abilities. Some are better conductors than others. The conducting ability of a material is indicated by a constant we call resistivity. So we have the formula: the resistance is equal to, this is our resistance, it is in ohm, is equal to the resistivity constant of the material, the unit is ohm meter, times the length of the wire, it is in meter, over the thickness or cross-section area of the wire, cross-sectional area, which is in meter square. Let's make an example. We have two wires A and B with circular cross-sectional areas. They have identical lengths, so LA is equal to LB, let's say L. They are made of the same material, so the resistivity of A is equal to the resistivity of B. Yet the wire A has 4 times the resistance of the wire B. How many times greater is the diameter of wire B than wire A? Now this clue we are going to use. The resistance of A is 4 times the resistance of B. Now let's put the formula. We know that the resistance is equal to resistivity times length over the thickness, which is equal to PR squared, because it has said that it has a circular cross section. So the thickness of the circular cross section area is the area of the circle, which is equal to PR squared. So R times L over P times RA squared is equal to 4 times the resistivity of B, you know that they are equal, the length of B, you know that they are equal, over P times RB squared. So when we cancel the same units, we find that RA squared over RB squared is equal to 1 over 4. So the ratio of the radius is equal to 1 over 2, so as the ratio of the diameters, which is equal to 2 times the radiuses, again 1 over 2. The cross-section areas and the lengths of the conductors K, L, M they are made of the same material are given, and the relationship between their resistances are asked. So as they are made of the same material, they have the same resistivity constant. The resistance of K is equal to resistivity times length over thickness, which is equal to rho L over A. The resistance of L is equal to rho L over A, which is equal to K. And the resistance of M is equal to rho 2L over A. So you see that the resistance of M is bigger than the resistance of K, which is equal to the resistance of L.